So you've heard of Ethereum, right? And maybe you just think of it as another cryptocurrency. But honestly, that's just scratching the surface. The real vision here is so much bigger. We're talking about a single global computer that no one, and I mean no one, can shut down. Let's dig in and figure out what that actually means. For most of us, when we hear the word blockchain, our brain just screams Bitcoin. And yeah, that's where it all started. A super secure, decentralized way to send value from point A to point B. It was absolutely revolutionary. But what if you could do more with it? Like way more than just tracking who owns what. What if you could run any computer program you wanted on that same network and know for a fact that it could never be censored or taken offline? That is the big what if question that led to Ethereum. And that's exactly where Ethereum jumps into the picture. It took that core blockchain idea and basically gave it a super-powered brain. It went from being a simple ledger for money to a fully programmable platform. The goal wasn't just to move digital cash around, but to build a whole new internet of applications, what we call dApps, that don't need a central company to run them. Okay, so to really get why Ethereum was such a massive leap forward, we gotta rewind a little bit. We need to look at the problems it was actually designed to fix. And that means understanding the limits of the tech that came before it. See, early blockchains like Bitcoin were built to be simple on purpose, which was great for security, but it came with some serious handcuffs. The programming language was incredibly basic. It had this thing called value blindness, which just means a transaction could send money, but it couldn't handle complex rules. It was all or nothing. It also had a lack of state, which sounds technical, but really it just means it had a terrible memory. It had no idea what happened in the past. And maybe the wildest one, it was blockchain blind. A program running on it couldn't even see basic data from the blockchain itself. So Ethereum comes along and says, we can fix all of that. It was designed from the ground up to smash through every single one of those limitations. This wasn't just a simple upgrade, it was a completely new way of thinking about what a blockchain could be, a true world computer that anyone could build on. And this whole idea kind of exploded onto the scene in a white paper from a super young programmer named Vitalik Buterin in late 2013. Things moved fast. Development kicked into high gear the next year, and by July 2015, boom, the first version of the Ethereum network was live, and the floodgates were open for developers. Now, the absolute heart of Ethereum is something called a smart contract. And don't let the name fool you, it's not a legal thing, it's just code. The vending machine analogy is perfect. You put money in, you select what you want, and the machine gives it to you. That's it. The code just follows its programming every single time with no middleman needed. So you take one or maybe a bunch of these smart contracts, you stitch them together to make something a person can actually use. And what do you get? A decentralized application, or a dApp for short. And here's the kicker. Once a dApp is on Ethereum, it just runs. No single person or company can change the rules or shut it down. All right, unstoppable world computer. Sounds awesome, right? But how in the world does it actually work under the hood? Let's peel back the layers and get into the nitty-gritty of how accounts, transactions, and the fuel that powers the whole thing really operate. Okay, on Ethereum, there are basically two kinds of accounts. First, there's the kind you would have, called an externally owned account, or EOA. You control it with a private key, and it's the only kind that can kick things off. Then you have contract accounts. These are basically robots, controlled by code. They can't start anything on their own, they can only react when someone else tells them to do something. And this picture makes it super clear. See the person on the left? That's you, with your EOA. You're the one who starts the action. You send a message, and it's like you're tapping that contract account on the shoulder, telling it to wake up and do its job. It's really cool, because it means every single thing that happens on the network starts with a real person making a choice. So that message we're talking about, that's what we call a transaction. It's basically just a little secure package of instructions. It's got who it's going to, what's being sent, any extra data for the smart contract, and, this part is crucial, the fee you're willing to pay to get it all processed. And that fee is all about something called gas. Honestly, the easiest way to think about it is like fuel for your car. The Ethereum network is the engine, and to make it run, you need gas. Every single little calculation the computer does costs a tiny bit of this gas. In this table here, it shows you that nothing is free on this world computer. A really simple task might cost, say, 3 gas, but something more complicated, like storing data on the blockchain, costs a lot more. It's a brilliant system, really. It prevents people from writing bad code or creating infinite loops that would just clog up the network for everybody else.
So, what happens if you run out of gas halfway through? Well, everything just stops. Dead. Any changes get completely erased, like it never even happened. But, and this is the important part, you still have to pay for the gas you used up until that point. It's a key security feature to stop people from just spamming the network with junk.
Okay, so this power to run any code you want, it unlocked something massive. It was like opening Pandora's box in the best way possible. Suddenly, anyone could create their very own digital assets, their own tokens, that live right on top of the Ethereum blockchain. And when I say they can represent anything, I mean anything. A token could be a digital dollar, it could be a share of stock in a company, it could be the digital deed to your house, or it could just be loyalty points for your favorite coffee shop. The sky is absolutely the limit. Now, to make sure all these different tokens can play nicely together, the community came up with some rules, or standards. The two big ones you'll always hear about are ERC20 and ERC721. ERC20 is for fungible tokens. Fungible just means they're all the same. You know, a dollar bill is a dollar bill, right? They're interchangeable. That's ERC20. Then you've got ERC711. These are non-fungible tokens, which you probably know as NFTs. Each one is totally unique. Think of it like a famous painting. There's only one. That's an NFT. But here's the thing. Ethereum isn't finished, not by a long shot. It's this living, breathing project that's constantly evolving, with developers always working on huge upgrades to make it faster, more secure, and more sustainable. For a long time, Ethereum used the same energy-hungry proof-of-work system as Bitcoin. But in September 2022, they pulled off this incredibly complex upgrade called the merge. It switched the entire network over to a much, much more energy-efficient system called proof of stake. And they're not stopping there. The next big thing on the horizon is sharding, which is a fancy way of saying they're going to split up the workload so it can handle a crazy number of transactions all at once. So, from breaking past the limits of Bitcoin to kicking off this whole new world of dApps and digital assets, Ethereum has totally changed the game. The vision of a world computer is, well, it's huge, and the tech is still growing and changing, which really just leaves one big question for all of us. What are we going to build with it?